Hi, my name is Marcel. Welcome to the fifth topic in our Gentle Introduction to GIS series. In previous topics, we looked at vector data. We saw that vectors have a geometry, either point, polyline, or polygon, that are made up of vertices. In this topic, we will take a closer look at raster data. Raster data are different to vector data. They have no geometry. Instead, raster data sets are made of a regular grid of cells or pixels. Each pixel can be referred to by its column and row position. The raster grid is georeferenced. Being georeferenced means that the GIS knows where to display the raster relative to the Earth's surface. In this tutorial, we will load some different kinds of raster data and see how it can be used in the GIS environment. Let's take a closer look. One common form of raster data are scanned topo sheets. If you have worked with topo sheets in the classroom, these should look familiar to you. The data is created from paper map sheets and georeferenced. It's like having a paper map in your computer. Let's load a topo sheet raster. Click on the Add Raster Layer icon in the toolbar. Navigate to your local data directory under C, Program Files, Quantum GIS, GIS Data, Local, make sure that you have the files of type option set to GeoTIFF. Now select the topo sheet _clip file and then press OK. You will see an image appears in the map view. Notice how the image looks the same as a paper map sheet. Also note that compared to vector layers, which normally contain one feature type only, such as rivers, our raster layer represents many feature types. Another difference between raster and vector data is that raster layers do not have attribute tables. If I use the Identify Features tool to click on the raster, all I get back is a single number. The number represents the value of the pixel where I clicked. Let's add some tourism vector data that I created as part of the topic on digitizing. Click on Add Vector Layer and add the tourism _lines layer from your local folder. you will see that the vector layer lines up exactly with the raster layer. This is because the raster layer is georeferenced. Another thing you can see is that as we zoom in using the zoom in tool here, the raster layer starts to become less clear. In fact, if we zoom in enough, we can start to see that the raster is indeed just a grid made up of colored pixels. Notice though that no matter how much we zoom in, the vector layers always keep their nice appearance. Let's take another example of a raster layer. Click on the Add Raster Layer icon in the toolbar. Now choose NASA_JPL_clip.tiff. A new layer is added to the map view. Drag the layer below the vector layers. The last raster layer we opened looked like a topo sheet. This layer looks more like a photograph. It is an image by a satellite orbiting the Earth. Satellite images can be useful to use as backdrops for digitizing vector data. A satellite image is also a good way to understand the landscape. Many features cannot be represented well in vector layers. For example, all of these different vegetated areas would be hard to capture as vector data, but they are easy for your eye to detect in a raster image. Images that show on the screen in color achieve this by using 3 bands: red, green, and blue. If you open the raster layer properties by double-clicking on the raster layer in the legend, you will see the bands listed. You can change the appearance of the image by changing the band order. Let's change the order to 3, 2, 1 and click Apply. Some images have more than 3 bands, covering a range of the light spectrum from infrared through to ultraviolet. By using the band mappings, you can map those colors that would not normally be visible to the human eye to the red, green, or blue components of the image you see on the screen. You can also change the image to show as gray only by clicking on the single band in the raster properties and then click OK. This brings us to the end of our introduction to raster data. In our next screencast, we will look at vector topology. See you next time.